happens in another dimension. But then the question is, what created that other dimension? And you can keep going back and back, and you still don't know.
Yeah， 有些人认为是说它是发生在另外次元的，那别人就开始问你说另外那次元是怎么产生的，所以这是一个连续循环的问题。So it's more like philosophy, right?
Yeah.
Yeah. 就是不知道，佛曰不可说，不可说。Oh, actually, yeah, I was in another talk yesterday and talked to a Buddhism, a famous master in Buddhism, and she said that the Buddha said, "You don't say this, you don't say this. 不可说，不可说." And it turned out her interpretation is that it's not that you don't understand, you cannot explain it. It's just it's uncalculable. 无法计算的，都说是不能得出、算不出来的东西。它不是说不能去说它，而是说不能算出结果来的东西，不可说。Yeah, well, just one quick question. Back to this dark matter things, is that 暗物质有另外一个可能说是由那些 lower mass stars, failed stars, maybe a composition, another candidates for dark matter. Is that theory out of the question right
So
now?
it turns out that we can learn a lot about how much atomic matter there is in the universe, and we're almost positive that 4% of the universe, and this is another hour-long talk to explain why we know this, we can measure how much hydrogen and helium, for example, were created in the Big Bang. And that tells us that 4% of the universe is made out of atoms. If there was more, and so let's say there were failed stars, those are made out of atoms. And so we can't account for dark matter from being anything made out of atoms. It has to be made of something else.
Okay.
It cannot be made out of anything from atoms.
Yeah, 有另外一个理论，在过去20年里面说，暗物质是那种比较小的星星，就是星星质量太小了，以至于不能产生核反应，所以它很暗，你看不到，可是它会占多质量。但是呢，刚刚 Brian 说了，现在的理论算出来的是说，大爆炸之后呢，产生氢、产氦这种最原始的元素，来形成星星的，就只有4%，所以其他23个 dark matter 是不可能有原子形成的，所以这个理论已经除名了，不可能是正常的行星。
I'm curious about that we don't know what dark matters are, but we know how to know that the dark matters can run through the Earth.
Turns out, that's a good question, is that we do know some things about dark matter because we can see how galaxies are arranged across the sky. When I showed you that map of the universe where we weighed how much gravity there was in the universe, galaxies are not random across the sky. They form a foam, sort of a cosmic foam. And it turns out that that foam would not look like that unless the dark matter travels right through itself and through all atoms.
Yeah, 他说我们现在看起来星系的结构跟星系团的结构，应该是说让暗物质能够穿透的过去的。如果没有暗物质在中间穿透，或者是在旁边影响它的形成，今天这些星系的分布不应该像今天这个样子的。
Also, the bumps and wiggles of the cosmic microwave background can be predicted perfectly with this type of dark matter. If you get rid of it, then you can't predict it at all. It looks completely different than what we see.
对，今天这个暗物质的学说呢，刚好可以解释我们在宇宙微波背景辐射里面所看到的不均匀的区域，有些地方高，有些地方低，刚好用这个暗物质的理论可以解释的。Yeah, but people talk about dark galaxy. I mean, the galaxy is made total out of dark matter. Do we expect to see galaxy interaction cannibalism, dark matter?
Okay. So it turns out that one of the predictions of this type of dark matter is that for every galaxy like the Milky Way, there should be hundreds of little galaxies going around our galaxy. So 5 years ago, there were 10 galaxies known around our Milky Way. And so we thought that this type of dark matter had some serious issues, that it had some problems. However, we have now, in a survey in the northern hemisphere, and we're beginning a survey in the southern hemisphere, found 30 new galaxies. And these are interesting galaxies because they have almost no stars in them, but when we measure the gravity, they are just as heavy as the galaxies that have lots of stars in them. So it seems there may well be lots of little dark galaxies that have no stars in them at all. And so they're almost impossible to detect.
How were they detected?
Well, these are being detected because they do have a few stars in them. But normally for every piece of dark matter, every, solar mass of dark matter, you have a sixth of a solar mass of atoms. In these cases, these galaxies are 10,000 to 1. For every solar mass, every sun in them, there's 10,000 times more dark matter. So they're almost galaxies, all of dark matter.
Yeah， 就是说我们现在的所了解的是说，星系旁边大概有8到10倍星系本身的质量的暗物质在旁边，这是我们现在了解我们的星系跟周遭的星系。但现在越来越多的证据显示的，有一些星系离我们其实也远的，它里面有一个太阳，旁边就有1个暗物质所构成的行星，所以他们找到了找到了一些星系哈，几乎里面没什么星星的，所以没什么星星，可能也是几万几十万的哈，但是旁边的物质多的看不到。所以现在似乎看到了系 ，so we can say that those galaxies are made most out of dark matter, with only a small portion of visible matters. 只有一部分是可以看到，其他多半就是暗物质的。Oh, interesting.
Well, I'm happy to answer more questions to people if they want to come up afterwards.
Yeah， 就是 Brian 讲是说，如果大家还有问题的话，或许我们结束了以后哈，可以再来问问题。不过我希望 I hope that we will have this honor to escort you through the exhibition so that you will see what's going on there. 我也希望说我们能够陪着他，让他看一下我们的特展。那我问一下我们各位来宾，已经看过特展的请举手。OK， 好，谢谢。没有看过特展的，拜托去看一下，那是我们费尽心血做出来的东西。OK， It's really our honor and pleasure to have Brian here and give us a wonderful talk and answer so many interesting questions. Let's give Dr. Brian a applause again. Thank you very much.
And thank you to everyone that helped bring me here, the Australian government, yourself. Thank you so much.
Yeah, okay, thank you. 也谢谢澳洲工商协会在台的办事处，谢谢。